Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, Tuesday's here already. Tuesday. Just got Tuesday, Wednesday, Thursday. And notice my shirt. Okay? As you see, you have a Christmas Aloha shirt on. I do. But I wish they made Easter Aloha shirts. Now, granted, the birth of Jesus, God's Son, really important. But how about the resurrection? Oh, baby. Super duper important. So, I'm thinking somebody needs to make Easter or resurrection Aloha shirts. Boy, I'd be all over those. Talk about celebration. Okay? Big time celebration on all of that. Okay, so journal's out, huh? So in your journal, you're going to want to make sure you have divine design data on the gray whale. And I'm going to show you a picture in a minute and tell you the major points. So if you don't have it in your journal, you're going to stick it in there, right? So remember, I'm going to be looking for all this stuff in about 6-7 weeks. So you're going to want to make sure you put this all in. So I'm not trying to make it a threat. I'm simply saying it's going to be worth X amount of points, maybe 30 to 40. And if you rarely write in it, you're going to get, 25 out of 40. Or 27 or something. That's like 60%. So won't help the average much. So I'm just encouraging you, pick up those journal points, especially at the end of the year when you really want help to strengthen your science average. So I'm just saying. Okay. This Thursday you've got a test, right? So test Thursday. I am posting tonight. You'll be able, in fact, it'll be up by tonight. You will see in Wednesdays, so I'll post it ahead, Wednesday's homework notes, all the topics that Thursday's test is going to be on. I'd say it's going to be at least 40 points. It could be 50. Now, it might not be, but I would say there's a good chance it's going to be 40 points. So it's not a teeny-weeny test. Okay, it's a BFT. It's a big fat test. So you'll want a triple R, like starting tonight. Now, first, I've got kind of an order I want to go through. So I want you to see this. So I've got a number of pictures to show you. For starters, here it is. Okay, have a look at this. Is this cool or what? That, my friends, is a gray whale. And showing off. Coming up to a whale watch boat and showing off. Now the grays migrate down to some lagoons down in Baja California, and they'll come right up to the boats. And like you saw in that video, that baby came right up. Well, you see the baleen. I can't tell. This could be a baby or a juvenile that hasn't headed north yet with its mom. But you can see that whitish yellow baleen. It's a filter. What is its job? Well, the gray whale, it eats tiny little crustaceans and invertebrates on the bottom of the shallow ocean. So it'll turn its head sideways, scoop up a bunch of mud, and then squirt the mud back out with the water, and the little invertebrate animals are trapped inside, and down they go. So that's the way they feed. So not an accident. How long can the gray whale wait around for its baleen? Well, it can't. It needs it immediately, like every living thing. It's got to have its equipment and instincts right now, and evidence God made them. It's just silly to say, well, they gradually change, and develop baleen or whatever. Other divine designs of the gray whale, it has a streamlined shape to knife through the water. It's got thick, fat, blubber, to keep it warm, to insulate it. So, and one of the reasons the baby gray whales are born down in these warm waters, similar to the humpback whales born in warm waters off of Hawaii, the babies have to put down layers of fat insulation so they won't freeze in the waters in Alaska where they head up to. So, and they've got to develop their baleen in the case of the gray whale. So anyway, pretty cool. I hope you like that video. I love that video. That is an awesome video. So I wanted you to see that. So then I want to show you this. I'm going to have you write John 1:3 on Thursday. And here's John 1:3. Have a look. Mr. C, are you showing us Greek again? I am. You know, the New Testament was originally written in Greek. So the Old Testament in Hebrew. So this will be a bonus point. Some of you are going to write this down in your journal and go, I'm getting that bonus point on Thursday. Here it is again. I showed you this in Colossians. In Colossians, there was a Greek word, panta. It's right at the start of John 1:3. Can you see it over there? P-A-N-T-A. Panta. And what does it mean? All. Every. So, all things. So, literally, it's in this order. All things through him came into being, and without him came into being not even one thing. How do you like that? I love that. Has come into being. So, without Jesus, nothing, including not even one thing in the creation, came into being. That sort of rules out evolution, huh? Yeah. And remember what I'm telling you. We believers, we Bible believers, we Jesus believers, we believers in his resurrection. So we have all the science data because Jesus made everything. So the science data matches the biblical data. Now, evolutionists will say it doesn't. Well, in a number of cases they'll say something, and then finally the science data comes out, oh wait, that does match the Bible. Okay? The evolution idea, it's just thrown out there, but it doesn't make any sense. So the evolution idea is for people who don't want to believe the Bible, that God made everything. He didn't use evolution. He just spoke it into existence. Nothing instantly commanded, of course. Nick. So anyway, I wanted you to see that. So really cool. So what does panta mean? It's used in Colossians 1:16, I think. And then it's used here in John 1:3. And it's used several other places in the New Testament. And it means all. Panta. That's going to be a bonus point. So pretty cool. And I want to show you this guy. See if I can get it to come up.
Evidence from a bunch of some people who give evidences for the tomb.
Okay, this guy that you're about ready to see, I'm just going to show you just like 30 seconds of a video by Gary Habermas. He's got a PhD in history from Michigan State, and I've mentioned him before. He, in his PhD dissertation, that's like his research and paper, he proved historically the resurrection happened. And in his data, he cites almost all historians, believers and non-believers, and it's especially powerful, non-believing historians that don't believe the Bible's true, they still believe Jesus rose from the dead. Now, they don't believe it like you and I did. They believe historically something happened. He came back to life. They don't know what it is. They go, but I don't want to believe it. But the facts of history say he came back to life. So, and I told you last year when I was in Jerusalem, we were in the tomb. And what did the angels say to the disciples who had run to the tomb because they had heard rumors that Jesus wasn't there anymore. What did the angels say? He's not here. The tomb is empty. He is not here. He has risen. And that's why I've got goosebumps. And that's why we get so excited about Easter. Jesus is alive. You ask him into your life, he's alive in you. He's changing you. He's giving you strength. He's forgiving you. He's leading you, directing you. He'll never leave you. Does it make a difference to be a believer? Oh, yeah. Does it make a difference that Jesus came back to life? It makes all the difference in the world. So anyway, I want you to watch a little bit of Gary Habermas. I hope the sound is up enough. Here you go.
You get an article, and I can name them, but the articles, I know one article that gives 8 evidences for the empty tomb, according to critical methodology, or another one gives about 10. I've got 22 evidences for the empty tomb, all critically derived, not like, well, this verse says, all critically derived verses. So there's a lot of surprises. I'll give you one more. I do a minimal facts argument, and I use basically 6 minimal facts. Well, the 2 criteria I use is that I won't use a fact that's not multiply evidenced from a bunch of different sources. And secondly, because of that, the vast majority of scholars in the 90-something percentile allow its historicity. Well, everybody grabs onto this one, everybody concedes it, and I'm almost never asked, how do you know these facts are true? So I put a list together, and if you count all the individual pieces of data that accredit these 6, it's over 100. Over 100, here's the key, critically ascertained facts that the critics would agree to. That's why the critics don't disallow the facts. We're playing their game. So those are some of the surprises in the book.
So you get what he's saying. Now he's speaking to adults, okay? But here's what he's saying. The critics who don't believe the Bible, they're not Christians, they're atheists, they still have to say Jesus, because of the facts of history, Jesus came back to life. Now in a way it's like science. It's the science of events that have occurred on a timeline since Jesus created everything. History is really a kind of science. So the facts of history, a kind of science, prove Jesus rose from the dead. Well, the Bible says that too. So I tell you, we've got the Bible facts and we've got the facts of science, aka history in this case. This guy is brilliant. He goes all over the world presenting the facts that Jesus rose from the dead. And he doesn't get much argument. I mean, he always wins a debate when he debates other people who are atheists and want to debate him that Jesus didn't rise from the dead. Well, he goes, well, the facts of history say so, and most historians agree with those facts. Isn't that awesome? So I love this. So Gary Habermas, he is such a neat guy. So anyway, that's going to be on the test. I'm going to ask you for the pillars, the fossil pillars, and at least 1 evidence for each pillar. Really quick, I can do it in 2 minutes. Fossils, no tweeners, no ape men. Evidence for the worldwide flood. Old age. There is tremendous evidence. I've got over 100 scientific evidences that the earth is young. And you know what a number of them are. It's too hot. I'm going to show you some magma that comes out, which is lava in a little bit. Picture of it. And it shouldn't be hot anymore inside. It should have all cooled down a long time ago if the earth is billions of years old. So there's one of them right there. Another one of my favorites is, why do the bones of dinosaurs, a number of the bones of dinosaurs, fossilized dinosaur bones, they haven't mineralized enough? Because it takes a long time to harden up a bone, a fossil bone. Well, they haven't been in the ground long enough. So, and there's DNA in some fossilized dinosaur bones. Shouldn't be there. It should have broken down in a few thousand years. Red blood cells shouldn't be there. Should have broken down in a few thousand years. Accident pillar, law of cause and effect, law of biogenesis. Life can only come from life. So, and things are way too complex, and living things need their equipment and instincts right now, just like the gray whale. Can't wait around for baleen. So got to have it right away to operate in their habitat. So then you've got the M pillar. Mutations stink as a mechanism. Stink. What are they? Harmful. They are rare, and they're often fatal. So this is the mechanism that's supposed to make living things change for the better. Not. And then the natural selection pillar, it doesn't make things change. It just gets rid of anything that does change in a kind of living thing on the earth. And then the Big Bang. There's so much evidence against the Big Bang. And chiefly, where did the particles come from in the beginning? Why would they attract when they don't have enough mass? Why would there be rotation of all the space bodies, including moons and planets and stars and galaxies? Why are they rotating? An explosion is not going to cause rotation, and especially everything to rotate, and it's just not going to happen. So, and then the spacing of the galaxies, there's a spacing. It's not random, there's a spacing, a repeating pattern. So, and there's a bunch of others too that you know about. So anyway, I'm going to ask you about all of those. So, and then I'm just checking to make sure I've got all this dialed in. Okay, how are we doing time-wise? Good. Okay, we're halfway through. I'm not going to do a break right now. I don't think it's necessary just now. But I want to show you this. I want to teach you the 3 kinds of rocks. Now, the 3 kinds of rocks, I like to teach them this way. S-I-M. Mr. Chambers, would it be a good idea if we put these in our journal? You know it would. It would be a great idea. I'd stick these in your journal if I were you, and they will be on Thursday's test. Here are the 3 kinds of rocks. S-I-M. SIM. And it's an acronym. S is for sedimentary. Sediment rocks that got squished by the layers of sediment above and formed into rock. Sedimentary rock. Now, I want to show you, I've got examples of these. So let me show you some sedimentary rock. Here's some right here. This is sandstone, probably Arizona sandstone. Sandstone is made by little grains of sand that get squeezed together by the layers of sediment above. So there's heaps of it, and there's heaps of it in the Grand Canyon. But right here in the Phoenix area, in Papago Park, nice sandstone in Papago Park. Out here in Mesa, Red Mesa, I'm not sure of its name, but I think it's called that. A lot of sandstone, beautiful. I love sandstone, it's so beautiful. Look at all the gorgeous colors of the sandstone. Isn't that pretty? But anyway, these layers were laid down rapidly by the Great Global Flood. Remember the major evidence about sedimentary layers. You can't see in between the layers like in the Grand Canyon, but I don't think this is a Grand Canyon, but it's near the Grand Canyon. So if you examine in between the layers of sedimentary rock or other kinds of sedimentary rock like shale, so they're smooth. And why is that? Because other layers were laid down rapidly on top of them, most likely by the Great Flood, the Great Global Flood. If they had been exposed to the environment for a long period of time, and if those layers of rocks are billions of years, there would be indentations and rough edges in between the layers. They're smooth. That's a massive evidence that they were laid down rapidly. So sedimentary rock, so sedimentary, sedimentary rock. And then the I one, igneous. It's liquid rock. It's magma that's come out of the ground, and then it's lava, right? Now, I've taught my 6-year-old granddaughter, she just turned 6, and I do this with her, and she can repeat this back and thinks it's kind of cool, pardon the pun. So not so cool actually, right? Magma and lava. So anyway, here it is. Magma, 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 lava, 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 lava. Magma, 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 lava, 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 as it runs out. Let me show you some of that. I think I've got some to show you. And here it is. It's magma inside the earth. And then when it comes out, it's lava. Magma, 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 lava, 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 as it flows out. Just trying to give you an auditory assist, a little brain glue, auditory brain glue, help you remember. Now the temperature of lava. I did a little looking, anywhere from 600 degrees Fahrenheit up to over 2,000 degrees Fahrenheit, depending on the kind of rock. Okay, so here I've got some for you. I want to show you. Pretty sure I've got some right here. These are igneous rocks or lava rocks. And have a look at them. There's the glassy one called obsidian. Do you see that? Now we've got a bunch of big chunks of granite around campus. Do you see the granite over there on the left? It is a igneous rock either formed underground and then it comes out, or it's squeezed out and then it cools. So some of the other ones you know about, basalts, is squeezed out from underground on the bottom of the ocean, basalt, and squeezed out of the continents, and that's granite, kind of the major igneous rock. So you've got sedimentary, then you've got igneous, that's it cooling down and hardening, and then you've got a third kind, the M, it's metamorphic. What are you talking about? Well, it's one kind of rock that gets heated, that's the and squeezed, and then it turns into a second kind of rock with different kinds of crystals. So metamorphic. So SIM, sedimentary. Hey, do these with me. It would help you. Yeah, do them with me. Come on the count of 3. We'll do SIM, sedimentary, igneous, and metamorphic. All right, do them with me. Okay, here we go. Please, everyone, participate. Okay, 1, 2, 3. Sedimentary, like shale or sandstone. Igneous, and it hardens like obsidian or granite. And then metamorphic, gets changed from one kind to another, like shale into slate. I think I've got some to show you here. Yeah, have a look. Here are different kinds. So over on the right you've got shale, and it's heated and squeezed, and it forms slate. And then you've got sandstone, and it, because of heat and pressure, do you see that? It becomes quartzite. See that? Sandstone right in the middle becomes quartzite. Shale to slate, sandstone to quartzite. Those are metamorphic rocks. Nice examples. So, anywho, I wanted you to see those. Hopefully you put those down in your journal. Now you're going to see a little video in a little bit on the 3 kinds of rocks, just to remind you what they are. A geologist is going to show you, tell you what they are, and examples, just like I did. So if you didn't quite catch everything for your journal, the SIM, sedimentary, igneous, and metamorphic, then you'll want to stick that in your journal. And you'll want to put magma, melted rock, underground, magma, and then lava. I'll ask you that on Thursday. What is melted rock underground? Magma. What is melted rock that comes out of the ground? Lava. So I'll ask you those. So I love telling you what I'm going to ask. Mr. Steve, how come you're always telling us what you're going to ask, the topics? I want you to remember them, that's why. I don't want to just test you on them and then move on to something else, and then you forget all of it until during the semester exam you've got to memorize them all over again. That's not my style as a teacher. I want to give you brain glue, and I want you to remember them for a long time. So, anywho, let's see what else. So, those are pretty much, I think, the major things. So your homework tonight is, by the way, you've got homework on the 3 kinds of rock. That's got to be passed in. I ask you to write it on separate paper. So please pass that in. Make sure name, date, and period is in the upper right-hand corner. Pass that in, please. Mr. Phillip will scoop it up. you're going to watch this little video on the 3 kinds of rocks. It's a pretty neat little video. I'm not going to say cool because some of them are hot, actually. So, and your homework tonight again is triple R, everything that's going to be on the test. Now, I forgot to remind you about this, and I do have these to show you. And I've got the 3 minutes to show you. I'm going to ask you about the standard model. What is the standard model? The standard model is like a chart of the major kinds of atomic particles. What are the major kinds of atomic particles? Well, you can see over on the left, quarks, and then leptons. Leptons, one example would be electrons. So I'm going to ask you what the standard model of elementary particles is, or basic particles. I'm going to ask you for the 4 fundamental forces. Here they are. You've got gravity. Thank you, Isaac Newton. And then you've got electromagnetism. Opposite charges attract, like charges repel. Then you've got the weak force that involves the breaking down of atoms, the decay of atoms. Like uranium breaks down into a number of other things, a number of other elements. And the weak force is responsible for fusion on the sun. Thank you, God, for fusion. So there's a divine design for you, the fusion process on the sun. And then you have the strong force. Notice it's showing a force holding the nucleus of atoms together. Holding those protons together, they should repel each other, right? But they don't because of the strong force. Then I'm going to ask you, what's the basic particle of an element called? You're going to say, oh, that's an atom. What's the basic particle of a compound? Oh, that's a molecule. How do you get a compound? Element, element, compound. Element, element, compound, like H2O. H2, hydrogen, O, oxygen. Make H2O combine, hydrogen and oxygen combine to make water. Well, anyway, so I'm going to ask you about all those. And then I'm going to ask you about this. If I still have it up here, I think I do. This is the LHC. I made a big deal about it. Look at the one guy standing there at the bottom. That baby is big. Compared to the guy down there. What is LHC? Large Hadron Collider. What are hadrons? They are protons or neutrons. So what does the collider do? It collides or smashes protons together. Why? I'll ask you this. What's the purpose of all of this? To find out what the smaller particles of atoms are. And one of the particles that they found in 2012 was the Higgs boson. You saw it on the standard model over on the right. And the Higgs boson shows that there's a Higgs field that all particles go through and are held together by. And they have mass. So anyway, we can't see the Higgs field, but we can see, because of the Higgs boson, we know it exists, and we can see what it does. It gives mass. And I'll ask you this. It's the hardest question I'm going to ask you on Thursday. What does the Higgs field do for particles, atomic particles? It gives them mass. That's what it does. Is it mysterious? Oh, yeah. Does it give much glory to God? Oh, yeah. So it is amazing. So anyway, there's a nice little review, triple R, all of that. And I'm going to turn it over to Mr. Phillips, and he's going to show you this little video on the 3 kinds of rocks, SIM. Sedimentary, igneous, and metamorphic. Mr. Phillips, thanks.